Welcome back. Before we start our deep dive into today's topic, please take a second to hit that like button, subscribe to the channel and turn on notifications so you never miss a technical breakdown. It really helps the channel grow. Welcome to this comprehensive tutorial on Apache Kylin. In today's data-driven world, organizations need to analyze massive datasets in real time. Apache Kylin is an open-source analytics engine that enables sub-second query performance on big data. Originally developed at eBay, Kylin is now a top-level Apache project and is widely used in enterprise environments for interactive data analysis. So what exactly is Apache Kylin? It's an open-source distributed analytics engine that provides SQL interface and multidimensional analysis on large datasets. Built to run on Hadoop and Spark, Kylin precomputes data into OLAP cubes, enabling extremely fast query responses. This makes it ideal for business intelligence, dashboards, and exploratory analytics on massive datasets. Why should you consider Apache Kylin for your analytics needs? First, its precomputed cube architecture allows for sub-second query performance, even on petabytes of data. Second, it supports standard SQL, making it accessible to analysts and data scientists. Third, it's highly scalable and integrates smoothly with existing Hadoop ecosystems and by tools like Tableau and Power BI. Apache Kylin offers several core features that make it stand out in the big data analytics space. It provides a SQL interface for querying, supports precomputed OLAP cubes for performance, and integrates with real-time data ingestion systems like Kafka. Additionally, Kylin works seamlessly with popular BI tools, making it easy to build interactive dashboards and reports. Let's take a high-level look at Apache Kylin's architecture. At the bottom is the data source layer, which includes systems like Hadoop HDFS and Kafka. Above that is the cube computation engine, where data is aggregated and indexed into cubes. Finally, the query engine and API layer handle user requests and deliver results via SQL or REST APIs. Data ingestion is the first step in the Kylin workflow. Kylin supports both batch and streaming data ingestion, pulling data from sources like Hadoop HDFS or Kafka. It can process structured data from Hive tables or semi-structured data from logs and events, preparing it for cube building and analytics. Once data is ingested, Kylin begins the cube building process. This involves aggregating and indexing data based on defined dimensions and measures. The cube is partitioned for performance and stored in systems like HBase or Parquet. This precomputation is what enables Kylin's ultra-fast query performance. Querying in Apache Kylin is straightforward thanks to its SQL interface. Users can connect via ODBC, JDBC, or REST APIs. Kylin optimizes queries by pruning unnecessary partitions and leveraging precomputed aggregations, ensuring responses are returned in milliseconds, even for complex queries. How does Apache Kylin compare to other analytics engines? Compared to Hive and Spark SQL, Kylin offers much faster query performance due to precomputed cubes. Unlike Druid, which is more flexible for real-time analytics, Kylin is optimized for structured, pre-aggregated queries. It's ideal when you know your query patterns in advance. Let's look at some performance benchmarks. Apache Kylin consistently delivers sub-second query response times, even when querying petabytes of data. Its architecture is optimized for read-heavy workloads, making it perfect for dashboards and interactive analytics where speed is critical. Let's explore a real-world use case: e-commerce analytics. Companies like eBay and Telecom use Apache Kylin to analyze billions of transactions in real time. They track customer behavior, segment users, and generate reports for sales forecasting, all with sub-second response times. In the telecom industry, Apache Kylin is used for network performance monitoring and customer analytics. Providers analyze call detail records and network logs to detect anomalies, optimize performance, and understand customer usage patterns. This helps in proactive maintenance and improved service quality. Financial institutions use Apache Kylin for fraud detection. By analyzing massive volumes of transaction data in real time, Kylin helps detect suspicious patterns and anomalies. This enables financial institutions to score risks and trigger alerts instantly, protecting both customers and the institution. Let's summarize the pros and cons of Apache Kylin. On the positive side, it offers ultra-fast query performance and seamless SQL integration, making it easy to use with existing BI tools. However, it requires significant resources during cube building and is less flexible for ad hoc or exploratory queries. Apache Kylin integrates seamlessly with the Hadoop ecosystem. It works with HDFS for storage, Hive for metadata, and Spark for computation. It also supports Kafka for real-time ingestion and integrates with popular BI tools like Tableau, Power BI, and Superset for visualization. When designing cubes in Apache Kylin, it's important to define dimensions and measures carefully. Use partitioning to improve performance and avoid creating overly wide cubes, which can impact build time and query efficiency. Proper design ensures optimal performance and resource utilization. Apache Kylin supports both batch and real-time processing. Batch processing is ideal for historical analytics, while streaming ingestion via Kafka enables real-time insights. Many organizations use a hybrid approach, combining both for comprehensive analytics capabilities. Apache Kylin uses several optimization techniques to ensure fast query performance. These include partition pruning to skip irrelevant data, aggregation pushdown to reduce computation, and query rewrite and caching to avoid redundant processing. These optimizations are key to Kylin's speed. Metadata management is crucial in Apache Kylin. Metadata, including cube definitions, data models, and job statuses, is stored in HBase or a relational database. Kylin supports metadata versioning and auditing, ensuring consistency and traceability across analytics workflows. Apache Kylin comes with a powerful web-based UI for managing and monitoring analytics workflows. Users can design cubes, monitor build jobs, run queries, and view query history. The intuitive interface makes it easy for both developers and analysts to work with Kylin. For developers, Apache Kylin provides a REST API and SDKs for Java and Python. These tools enable programmatic access to Kylin's features, allowing for automation of cube building, querying, and integration into custom applications or data pipelines. Security is a key aspect of Apache Kylin. It supports authentication and authorization, role-based access control, and integrates with LDAP and SSO systems. These features ensure that only authorized users can access sensitive data and analytics resources. Monitoring and logging are essential for maintaining Kylin in production. Kylin provides real-time monitoring of cube building jobs, detailed performance and error logs, and integrates with monitoring tools like Grafana and Prometheus for centralized observability. Apache Kylin can be deployed in various environments. It runs on-premises on Hadoop clusters, in the cloud on platforms like Oz and Azure, and even in containerized environments using Kubernetes. This flexibility makes it adaptable to different infrastructure needs. Managing a Kylin cluster involves resource allocation, scaling strategies, and high availability configurations. It also includes backup and disaster recovery plans to ensure data integrity and uptime. Proper cluster management is key to production readiness. Performance tuning in Apache Kylin involves optimizing cube design, tuning memory and CPU usage, and implementing efficient storage and compression strategies. These steps ensure that Kylin delivers optimal performance under heavy workloads. When troubleshooting Apache Kylin, common issues include cube build errors, slow query performance, and configuration problems. By analyzing logs, checking resource usage, and reviewing cube designs, most issues can be resolved efficiently. Apache Kylin has a strong community of users and contributors. The project offers comprehensive documentation, active forums, and commercial support options from vendors like Kyligence. This ecosystem ensures users have the resources they need to succeed. Looking ahead, the Apache Kylin roadmap includes cloud-native enhancements, better streaming support, and improved SQL compatibility. These updates aim to make Kylin even more powerful and accessible for modern analytics needs. Ready to get started with Apache Kylin? You can install it on a Hadoop cluster or use Docker for a quick setup. Load sample data, define a cube model, build the cube, and start querying via SQL or the Web UI. The official documentation provides step-by-step guides to help you begin. There are many resources to help you learn Apache Kylin. Start with the official documentation, explore online courses and video tutorials, and engage with the community through forums and GitHub. These resources will accelerate your journey to mastering Kylin. In the big data landscape, Apache Kylin complements tools like Hadoop and Spark by providing fast query performance on structured data. It serves as an alternative to Druid for pre-aggregated analytics and to Presto for interactive querying. Kylin fills a unique niche for performance-critical analytics. Many enterprises, including eBay and Telecom, use Apache Kylin for mission-critical analytics. It's widely adopted in industries like finance, telecom, and retail, where fast insights from large datasets are essential for business operations and decision-making. It's important to distinguish Apache Kylin from Kyligence, a commercial product built on Kylin. While Kylin is open source, Kyligence offers additional features like cloud deployment, enhanced UI, and enterprise support. Both serve different needs depending on your requirements. Apache Kylin is a top-level Apache project with a strong governance model. It's developed and maintained by a global community of contributors, with regular releases and updates ensuring continuous improvement and long-term viability. To succeed with Apache Kylin, follow these best practices. Design cubes carefully with performance in mind, monitor and tune your deployment regularly, and leverage the active community and official documentation for support and guidance. Thank you for watching this deep dive into Apache Kylin. If you found this tutorial helpful, please like, subscribe, and leave a comment with your questions or suggestions. Don't forget to explore related tutorials and try Apache Kylin yourself to experience its incredible performance firsthand. And that wraps up our explanation. If you found this useful, please hit the like button and share it with a fellow developer. Don't forget to subscribe for more technical tutorials. Thanks for watching, and I'll see you in the next one.